Everyone would like to lower their home heating, air conditioning, electricity, and water bills. But what are the most effective measures to take? How can they be implemented without spending a fortune? The Reading Cities for Climate Protection Committee spent a day learning the most cost-effective approaches available when we partnered with the Cambridge Home Energy Efficiency team to perform an energy efficiency and weatherizing makeover on an Arc of East Middlesex home here in Reading. The Cities for Climate Protection is a town committee formed in 2006 to develop and implement actions to reduce Reading's contribution to greenhouse gas emissions and support a sustainable environment. We have been working with the town manager and municipal departments to reduce the emissions generated by municipal buildings and fleet. We also focus on educating the community about climate and energy issues by offering solutions through public awareness campaigns and community events, and by promoting energy conservation. For this event, we partnered with HEET, a Cambridge-based grassroots nonprofit group formed in 2008 that uses a barn-raising model to teach volunteers hands-on how to lower their energy bills and carbon emissions. They consult with energy experts to pass on accurate information, they build community, and create social marketing for energy efficiency. They help facilitate the exchange of ideas. They were given the Go Green Award by the City of Cambridge in May of 2009 as the city's outstanding community organization working towards sustainability. We worked with Audrey Schulman and Jason Taylor.
Schulman, I'm with Jason Taylor. We're both from HEET, which is Home Energy Efficiency Team, and we are out of Cambridge. We started about a year ago, and we do evaluations of buildings to see where you can save the most energy, and we organize weatherization parties so that we teach people how to weatherize. At the same time, we actually weatherize a building and bring down the carbon emissions for that residence. And help people out with their energy bills. It's a really wonderful thing.
And I'm with the Home Energy Efficiency teams in Cambridge, and we're here to participate in a weatherization barn raising evaluation with a group that's starting in Reading, and we're hoping to do our best to help them out.
Another partner for our barn raising event was the Reading Municipal Light Department. That's our local municipal light company that provides electricity to Reading, Linfield, Wilmington, and North Reading. Jared Carpenter, the newly hired energy efficiency engineer, helped out at the workday by auditing the home's electronics, appliances, heating system, and lighting.
My name is Jared Carpenter. I'm the energy efficiency engineer with the Reading Municipal Light Department for mostly for commercial buildings, whether it's for solar or any other kind of renewable, or whether it's for programs just looking for ways to save energy. For residential, they're mostly rebate programs for appliances. And I perform most of the audits on commercial and residential buildings. If we need a more comprehensive study, we can bring in another team, but most of the time I go in there and do look for sort of the obvious things, and some of the return on investment studies, I'll do all those as well.
We worked on a house owned by the Arc of East Middlesex, a nonprofit charitable corporation founded in 1954 that provides and promotes services and supports for persons with intellectual disabilities and their families. They annually serve over 700 people in the North Suburban Boston area, and they own 3 homes here in Reading. Tina Clayton was on site to help with the day's activities.
I'm Tina Clayton. I'm the Director of Residential Services for EMA. This is a Hopkins Street residence. We currently have 5 individuals living in this program, 3 women, 2 men, all with a varying degree of developmental disabilities. The ladies are, in their 80s. This house was renovated in 2002, so it was pretty much kind of leveled and then everything redone for this program back in 2002. We were helped by HUD to do this, so a lot of it is pretty new.
Before we get started in auditing this particular house, it would help to better understand the mechanism by which a house loses its heat. Preventing heat loss from a house can be thought of in terms of preventing heat loss from our bodies. In cold weather, our bodies lose heat primarily through 2 main heat transfer mechanisms. Like the sun, our warm bodies radiate heat to the cold air. And when the wind blows by us, our bodies lose heat through convection to the air. So to keep warm in the winter weather, we need both an insulating layer like a sweater to stop the heat loss from radiation, and a wind-resistant layer like a windbreaker to stop heat loss from convection. Similarly, our homes lose heat through radiation and convection, so they also need an insulating layer such as fiberglass insulation and a wind-resistant layer, like that achieved through air sealing with caulking. Air sealing is the most cost-effective home weatherizing measure you can take, so that's the best place to start, followed by energy efficiency measures. It's important to understand how air flows through a house. Let's hear how Jason and Audrey explain that phenomena and what this particular house has in store for us.
As you may or may not know, heat rises and goes out the holes in your attic, and it creates a pressure that pulls in the cold air into your basement or the low parts of the house. So by sealing the attic holes, you're keeping that air from going out, obviously, and also keeping the air from coming into the basement. So that's the stack effect. It's like a chimney. Some people call it the chimney effect. Audrey!
Yeah.
Oh, can I see you? I see you.
Hello.
Hi. You have got to see this. I know you can't. There is a hole that's so big around the chimney that you can't believe it. And it's basically it's going through the thermal plane. So there's a huge amount of heat that's escaping through here. So you've got 6, 12, 18 square feet. That's like having a window missing from your house. This is a huge spot right here. But who would go up here? No one in their right mind would go up here. That's me included. This whole gap this is the thermal plane. This is a place for air to go from the basement all the way up through here and out basically out into the attic.
So I just got out of the attic, and as you saw before, it's a mess up there. So it's just a one-story house. The ceiling on the first floor is the thermal barrier. So any place that you can see through that, where there's a hole between that and it will basically mean that air is leaving through there, warm air. The main problem is a design problem where they have the heating system in the top of the house so that all the heat goes up and out the attic. So it's just not an efficient thing. Ideally, you would want to have the heating system in the basement so any heat that got away would just rise and go into the living space. So in this system, you have warm air being created in the attic. It goes down here, which is really inefficient, and then it's just going to go back up the holes up there.
What's important things are the things that are down low and the things that are up high, because that's what creates the convection, which is the force that pulls air. So one of the things we look for is the surface penetrations like this. This actually is pretty good because it has some caulking around it, but we'll check it from the inside when we have the blower door going on, and then we'll know for sure if it's sealed. These pipes as well.
This is one of the classic ones. Here's a dryer vent.
Oh,
and
yeah.
it's so filled with lint that the vent is never closed, which is like in every single building. Every single building. There's a little flap here. It's supposed to be shut, but it never is. And actually, this one's broken. But just, in your own house, just go around outside, pull the lint out, make sure the flap on the door is actually closed.
There's a lot of argument these days about whether it's necessary to ventilate the attics or not. This was something they started doing as a way of dealing with moisture getting into the house. But really, the way moisture gets into the house is when it comes in through the holes and goes out the holes in your attic. So it's that creates convection. And so you have a lot of wet air coming in and going up, and now building science is going in the direction that it's not necessary, but a lot of the inspectors are trained to look for these things that were never proven by science. So it's kind of a weird area.
Okay, but when he was talking about sealing the attic, he was talking about sealing between the house and the attic, not about sealing the attic to the outside.
No,
Right.
but to seal, like there's a lot of, if you go up in an attic and pull the fiberglass or whatever out of the way, you'll look down and you'll see big cracks where the electrical outlets come up or the pipes stack.
But that's coming from the house to the attic.
Yes, so
Right.
it's air sealing,
Yeah.
it's called the surface boundary.
If preventing airflow through a house is the most important step you can take in weatherizing it, How can you determine where warm air is getting out of your house and cold air is getting in? A blower door test is a great way to find these places. Jason will explain the blower door test for us, and then we'll see where the air is flowing in this house.
The blower door helps so much. It's really one of the most important things that you can do. Well, I already put together there's an adjustable frame that fits on it'll fit any door except like the hugest of doors. Good boy. And then if I put that in, you're gonna have to go around the other side or crawl through the hole. These little camshafts, or cams, I think they call them, not shafts. Okay, there we go. How much does it cost?
Yeah.
They cost about $3,000. Blower door tests are like the most important thing that you can do to your house to find the air sealing. I think I've said it like 3 times, but anyway, that's how important it is, and I have to say it 3 times. And a lot of people don't know what these are yet, but everyone's going to know what these are in the next couple of years. It makes a -50 air pressure in your house, -50 pascals. And so what it does is it pulls the air out of your house so that it creates air movement in the house, and you can walk around and you just can put your hand up or you can put incense up and you'll see where all the holes are. And it's the best thing. It's so great. And we'll find where all the holes are, and then we'll come back. Typically what we'll do is we'll put a blue piece of tape on it, and then we can come back and we can seal that particular thing. So that's it. So here we go. It gets a little loud, so. So now we wait for a little bit, and this will start the air movement. It takes a little bit of while for it to start, but to reach the whole house. But we'll be able to feel all the places where there's air coming through. I can feel it right here.
To the edge of it.
Oh yeah.
The air just blowing through the tape right down.
This is kind of heavy, actually. See a little bit there.
Yep.
Take a ceremony.
And then Jason's got some painter's tape, and if everybody takes a little bit of painter's tape and you just mark wherever you find a leak, and that way they know where to seal in a few weeks when we do the thing. Go ahead. No. You can also hold this near here, and the smoke is going straight that way. I don't know if you can see that well with the camera, but and you might not like the incense. The incense might be too much of a distraction. With your hand, you can really feel this. Might not make dark enough smoke. This is our first time we've tried the incense.
No, it's definitely going away from that. It's being pulled in. See how it's going away?
Yeah. And that tells us that the light fixture is not well sealed.
You can't even see. It's coming out so fast. You can't even see it. You can feel it too. If you put your hand there.
The top edge of the window frame has no caulking up there. You can see that the smoke is coming up from there as the blower door pulls the air out. I don't know if you can see the smoke was going straight up as it came out of from above here, so that sort of demonstrates that it's leaking around the window.
Here's a huge gap right here. I can feel the cold just pouring through here.
Okay, sorry. What'd you want me?
Wow. Oh my God. Is that it? Oh my God. That's huge.
Yeah.
So you can spray foam that. That's a real easy thing to do.
In addition to wasting energy through heat loss from airflow, a house uses a lot of energy through appliances and electronics. Homeowners can save energy by choosing appliances and electronics that are designed to conserve energy, and also by modifying their own usage habits. Jared walked around this house and pointed out ways to save electricity and heating fuel.
There's an electric stove over there, with some different sized burners and whatnot. Not a whole lot you can do about that since that's what it's designed to have. It's definitely an older model. I'm not sure how old exactly, but I would guess somewhere, I'd say early 2000 probably, maybe even 99, 98. So there are much more efficient models out there. It's not an Energy Star rated refrigerator, so that's not a good thing, but it's still not bad. It could be worse. Worth replacing down the road. The dishwasher, it has a choice for heated dry. So one smart move would be just to turn off the heated dry cycle. So it's really, the majority of your money really comes from having to heat things with electricity or having to cool things off with electricity. That's where a lot of your power goes to. So I would certainly turn that off if it was mine. I did at home actually. Turn off the heated dry and just let it air dry. Washing machine and dryer. The washing machine is a top load machine. Therefore, it's going to use a lot more water than a front load one does. Quite a few gallons more. So the extra water means it has to work harder heating the water, so it uses quite a bit more energy. The Energy Star rated ones will use less water, they'll be front load, and then also will spin more, so they will use much less washing time and more spinning time, much less hot water to have to clean the clothes. The best thing you can do is always wash clothes when you have a full load, because when you use a half load, a quarter load, you basically use the same amount of energy as a full load. And oh yeah, good one too. Also too, using as much cold water as possible. You really don't need hot water for certain kinds of whites or certain kinds of linens. So the reality is, use cold water for almost everything. The dryer too, there's not really a whole lot you can do about dryers. Dryers are just kind of pretty inefficient as it goes, because I mean you're creating hot air to dry clothes off. So worth replacing if they seem older. This one doesn't even seem that old. And always air dry. Clothesline is simple. It's essentially free. So hanging your clothes up, air drying in the summertime especially, easy option, great option. Regarding TVs, this is an LCD TV, I believe. Yeah, you can always tell because they're a lot lighter. LCD TVs are by far the most energy efficient. Next is a plasma, and then kind of the old style tube TVs. Best thing to do with TVs and game systems, and over like kids are playing the game systems, is just turn them off and not using them. I find game systems actually be a larger and larger energy consumer lately, because a lot of times people are playing a game and they don't want to turn it off. So they leave it on for hours and hours and hours on pause. So at the very least, turn the TV off and turn off the game systems when you can. Regarding a computer, the best thing to do is at least put on sleep mode. So if you're not going to be touching your computer for more than 20 minutes, it's good to turn it off. Same with printers and fax machines. There's even what you can put, there's called smart energy strips you can purchase, that you can program it so one has power going to the rest of them. So you have your monitor plugged into the one that goes to a live power, and everything's plugged into the rest of them. So when you turn your monitor on, it would turn all the rest of them on. When you turn your monitor off, it turns all the rest of them off.
Now that we better understand how a house loses its heat and where this particular home is losing heat and wasting electricity and water, we're ready to get to work improving it. Let's find out what our team leaders have in store for us.
I'm going to be doing, there's 2 attic hatches here, and I'll be creating boxes that go over them out of rigid insulation, the pink stuff here, so that there's some insulation over there. There's underneath every sink in here, there's a pipe that goes down in through the floor, and there's generally a half-inch hole around it, and so we'll be sealing off those 2 with spray foam.
So the 3 things that I'm going to be doing is, one, I'll be doing a little bit of mortar. There's actually holes, and everybody has these. If you'll start checking your own homes and stuff, but there's like 2 holes that are about this big, right in the foundation. They've just been there for years, and it's sort of like having a window open this much in your house for the whole year, and it's extremely inefficient. So we're going to do some mortaring with that, with a couple of bricks we'll put in there. Secondly, we're going to be sealing the van joists with a little combination of rigid foam, this stuff, the pink stuff, and also spray foam that goes around it. And the third thing I'm going to do is there's a special, it's a really forgiving weather sealing called Q-Lon. That's Q-L-O-N.
It's got about, I'd say 1.5 inches, maybe 2 inches of rubber gaskets. So a lot of doors are really crooked and not perfect. And this is very forgiving. So you can put it up against there, and even if the door's out of whack 1.5 inches, you're still all set, and it makes a really nice seal. So there's a big attic door that was very leaky. We're going to put the Q-on around that, and we're also going to put some door sweeps at the bottom, try to tighten that up around the bulkhead. So those are the three things: mortar, band joists, and the door.
I have some of the most technical, dirtiest jobs. I have some of the easiest, cleanest jobs that are the simplest things that are going to have a big effect. When Audrey was speaking about a 50 by 10 inch hole, we actually, on the other side of the ramp here, there is a window that doesn't exist. That is a 12 by 15 hole that we're going to knock off, among other things. That's going to be a really important job. We also have, people may have bay windows, the jut out windows, and underneath it is very well insulated by some pieces of 1/2 inch particle board that are falling down. We're going to, with holes that are already in it, we're going to be sealing that up with using, again, some of the rigid foam stuff. We're going to be going around the exterior of the house, caulking most of the windows, setting it up so that there's no air coming in through there. We're also going to be going around in some places where the foundation meets the sill plate to caulk along there, because there's, again, air coming in through there. And on the inside, there are, give or take, 365 recessed lights. We are going to be caulking where the plate meets the ceiling, pushing it back in place, because what happens right now is
we want to close them off because they're not being used in this house. So we can take sheetrock and put it around and seal it with caulking, and it'll stop the hot air from going through. And that'll save a lot of money. As well, we're going to replace these thermostats to make it programmable so that we can turn it down a couple of degrees and use the heat more efficiently. And the last will be a dryer vent that we're going to replace, because the existing one has some holes in it, so we'll put this back in there, and that should stop a lot of the heat loss that's going on.
So this is an EcoFlow water pick handheld shower head. It uses 1.5 gallons per minute, and we're going to test, before we replace the existing ones, we'll check and see what they use. Probably 2.5 or more gallons per minute. And so that's kind of simple. Then the other thing we're going to do is use these electrical outlet and switch sealers. They're foam gaskets that go behind the switch plate. Again, because air can actually travel through your walls. We have some compact fluorescent light bulbs. And EMARC had already done a great job of replacing quite a few of the bulbs, but I think probably your plan was to replace the incandescents as they burn out. But as, because those bulbs use only 1/4 of the electricity of an incandescent bulb, the energy savings is immediate, so it doesn't really make sense to wait till they burn out. So we'll go ahead and replace those.
Looks like our team leaders have a lot of work in store for us, so let's get to work. First up is Team 1 with the attic hatch insulation.
carrying it around.
Well, I was just thinking
This is all the way to the edge here, so you want to have to get back. Well, maybe. Okay. All right, so let's say it goes there. Oh, that's very close the other way, yeah. so many people have attic stairs, and they're generally, they have like a 1/4-inch plywood or something like that on the underside. And wood has an R value of 1 per inch. And so this is 1/4 inch, so it's maybe 0.25 R value, whereas what heat likes to rise, so you want to have a really good, a lot of insulation there on your ceiling. And so this way, that's 2 inches of rigid insulation, which has an R value of 7 per inch or 5 per inch, I've forgotten. But so instead of now 0.25 R value, we have something between R10 and R14 up there. And it's just a very simple sort of half shoebox shape that we've made out of rigid insulation and taped together with foil tape.
Let's see how Team 2's foundation hole ceiling work is going.
3 to 1.
3 this, 1
Start with 3 to 1. Go drier is better than. In fact, there's something they actually recommend that you do the mix dry first and then add a little water depending on how thick you need it to be.
So 3 to 1 then.
3 to 1. So that's one.
We
Oh,
are
I got it in my
mixing
pocket.
some mortar mix.
Here you go.
And what I think we're gonna do is, we haven't seen it yet, but I think we're gonna be, Bing and I are gonna be patching some holes.
You know the old.
I'm not sure where,
Cut once.
but we're getting ready.
Measure twice. Exactly. That's awesome. That's perfect.
Team 2 is also working on that leaky bulkhead door. Let's see how they're doing.
There's no insulation at all. These are just hollow doors, so it would really be helpful to have some rigid foam here.
And we should also just, spray foam the underside of this all the way around.
Yeah, it would
because
help.
It's not air sealed.
It would help. It would definitely help. It's all set. It's gonna work good. Yeah, that should be good. That's awesome. That's awesome. Yeah, 55 and 8. So, I need you to do some more cutting. We're going to take one of these big cut 55 and 8. But we're going to cut that piece off because we're asking. So, I need you to pen. If possible, I would actually like not there, if it's possible, to not get a gap in there. I don't know if it's possible.
Team 2's final project was insulating and air sealing the band joist.
Band joist or the rim joist, it's a place where the masonry ends and the wood framing part of the house begins. And from blower door tests that have been done for years and years, it's been discovered that it's an extremely leaky part of your house.
There's just, the foundation expands and contracts because it's made of cement at a different rate than the wood does, so when it gets cold in the winter, that gap increases quite a bit.
There's no
and you get some really nasty infiltration.
But how does
Every
it
band joist
It should be all
caulked and spray foamed.
So this is the band joist, and what we're doing here is we're putting 2-inch rigid foam, and we're going to use this great stuff foam to seal it in. And so we're air sealing it as well as we're insulating it to stop the cold from radiating in and conducting in. So this is 15 to 20% of energy lost in our houses is through the band joist. And the other big.
It's where the cement part of the house or the foundation meets the wooden part, and it's very leaky. When we test it with blower doors, we get a lot of air movement coming through there. So we've installed rigid insulation around there, and now we're spraying around the cracks that we have around the rigid insulation. And that way we're air sealing it so that the air won't come in through the basement anymore. The cold air will not enter anymore.
Team 3 planned to repair some of the basement windows. Let's check in and see how they're doing.
There is this is the basement window. I don't know if that's good. I guess it's better than nothing.
Well, the casement window has a metal frame. We can maybe do a rubberized gasket around it. You can hear, I don't know if you can hear the sort of whistling noise. air coming in here. It sounds like Toto's gonna go spitting by any minute.
These window frames are metal, and so we can sort of pull back everything and maybe caulk along here, although it does look pretty, comparatively tight, somewhat tight.
Another project that Team 3 was working on was insulating the bay window.
Oh man, this is really bad. Underneath here, it's just a piece of plywood. There's holes in it. This is a classic place for air infiltration. So what we would do with something like this is we would put some insulation under here, and then we would also air seal it too. You could either use caulking or spray foam. Spray foam's a blast. You got to be careful with your eyes. That's the only thing. And it also takes forever to get off your feet.
Before we actually install this, what we have to do we're going to lay a thick bead of this stuff around the perimeter of the piece, and then we're going to go all over the middle. Sick. We're going to jam that up in place. I have some long screws and what's called sealing washers or sealing buttons, if you've ever done sealing sheetrock.
Use that to
And
hold it up?
yeah, it gives it some heft, because otherwise the screw will just go straight through this. We're going to put all of these pieces in place. You guys weren't here, but what we're going to do is we need to leave a gap against the house, a gap in front of the faucet here. We're going to leave, when we put these in, we're going to leave a little gap in between here as well. And then we're going to take a can of foam. After everything's all in place, we're going to take a can of foam and have a field day, and somebody's going to get very messy. And I'll take care of that job if nobody else wants to. I wouldn't blame you if you didn't want to. Why don't I leave?
Jeremy, does this work? Does it have to be upside down?
It doesn't have to be upside down. Generally, it's best if it is, but you can't fit it. You can barely fit it in at all. So.
No?
Team 3 is planning to seal the recessed lighting inside the house. Before we check in on them, let's learn a bit about compact fluorescent lights and regular fluorescent lights.
You know the old CFLs where they have that cold laboratory light? You can get, they almost all are warm light now, so they look the light looks the same as a normal incandescent. So there's just every kind of CFL you could want now, and they're just wonderful. They don't deal well with hot, heat, or cold. So if you have to have them in a recessed fixture or outside or in some place where they're going to have huge temperature differences, you should get the ones that are meant for recessed or exterior or whatever else. They don't do, normal CFLs can't be dimmed, so that you have to get a dimmable CFL, or ones on a three-way switch where it can go, from low lighting to medium lighting to high, to all the way on. Those ones you should get also a three-way CFL. They do contain some mercury in them, so you should dispose of them correctly. It's less mercury than in a single can of tuna. So really it's not all that much, and people get hyper about it. It's a lot less mercury than would be created in a normal incandescent at a power plant.
In Reading, compact fluorescent bulbs and the long light fluorescent bulbs can all be brought for disposal to the DPW garage on New Crossing Road, which is across from where the Home Depot is, and right next to where the new Stop and Shop is.
This pack of 4 costs only $4, right? It's a little
Right.
bit of 4.
Yeah.
So you can you earn out within a month.
Save $220. Take a look at that, because it's again, once again, it's just smart to go efficient. It's if you're cheap like I am, you definitely want to do this, because who wants to turn down $220?
If you have tall ceilings and you have recessed lights, you have to change these once every 8 or more years as compared to once every year, year and a half. For me, that's a wonderful thing.
You see bulbs, these are T12 bulbs here, you can't see the camera, but there's old T bulbs here, and these are T8s here, so they obviously put some more efficient bulbs in here, probably on a nice electronic ballast, so that's a good thing. There's some changes down here. These things should, in fact, I listen to it now, there's magnetic ballast, these two T12s that aren't even running, they're still drawing energy, the bulbs are just burned out, but you can hear the magnetic ballast is still humming away. So this whole unit should really be taken out.
Now we're ready to check in to see how the team is doing sealing the recessed lights.
These are the coolest things. They've got these little nails. I always have to go and find a nail. They're built in. Of course, it's not long enough. But
The idea was nice.
building. So by caulking the seal between the can and the sealing board, it should avoid some of that. And the really good heat caulk is disgusting blood-colored red. So this is going to hide any mistakes, but not be quite as good in terms of dealing with the heat. But it should be just fine. I really should be able to smooth that. I get the feeling people that do a lot of cake icing have a real leg for caulking. That would not be me. Most important tool.
Team 4 was working hard to seal up the unused fireplace. Let's see how they did it.
Fireplaces are, there's something called the stack effect, which is that heat tends to rise. And it's named after actually chimney stacks, because if you think about it, every time you put a fire in the fireplace, the heat, all the smoke goes straight up. So there's several ways to deal with this. One way is to do this, if you're never using a fireplace, seal it over like this. It's simple drywall with caulking around it to air seal it in place. Second way, if you tend to use a fireplace, is something called a chimney balloon or a fireplace plug. It's a balloon that goes in there and you inflate it so that it blocks off the flue, blocks off the chimney, so that no air can go up. And then when you want to light a fire, you simply deflate the balloon, pull it out, light the fire. When the chimney's cool again, you inflate the balloon and put it back again. But it's supposed to work very well to stop the air from constantly leaving your house and going up the fireplace and heating the great outdoors.
Thank you. Team 4 also planned to install a programmable thermostat. Let's learn a bit more about why that's so important.
So basically, you go to bed at night, the thing shuts off by itself. Right before you wake up in the morning, you program it for a half hour before you get up in the morning. The heat comes on. All night long, you've been nice and snuggled underneath your blanket. The heat's been off, and yet you get out of bed in the morning, and the heat's magically on again. And it saves you 10% of your heating bill, which is a lot. I mean, if the average person, spends about $2,000 or $3,000, so you're talking $200 or $300 for the year. So if anyone here does not want their $200 or $300, I will take it.
Regarding thermostats, programmable thermostats are very good as long as you use them and program them to your lifestyle. If you're not going to be using it, turn it way down or turn it way up depending on the season, air conditioning, or just turn it off. this case, it's programmable and it's locked up, which is a good thing. Location is even an important factor to consider. For example, if you put your thermostat near a window, it's going to see much colder temperatures in the winter, so it's going to want to turn on sooner. So placing it in a location where it's as close to accurate, like this is actually a pretty good location minus being close to where a draft might come in from the attic. But still, it's a good location in that it's near a couple bedrooms, so it'll read a pretty accurate temperature. I find this quite a bit. I get a lot of phone calls from this back at the office from people that they want to leave the air conditioning on all day long because it takes more energy to cool the house off. Generally speaking, that is not the case at all. It's much easier to just have it off during the day if you're not there, and then have it programmed to turn back on within a half an hour of coming home or so. Occasionally will it be a little bit warmer when you come home? Sure, occasionally it will be. But 99% of the time it'll be perfectly comfortable. Leaving on during the day does not save you energy. It doesn't save you energy.
Team 5 focused on installing water conservation devices. Let's check in with them.
So what we're going to do is, before we change out the aerator on the sink, we're going to check the flow rate by turning on the tap, timing it for 5 minutes, and seeing what level it comes to in this 5 seconds. Okay, ready?
Mississippi 1, Mississippi 2, Mississippi 3, Mississippi 4, Mississippi 5.
Here we go. Wow.
Yeah.
This is low already, so we don't need to replace this one.
Oh, wow.
It's great. So we're going to turn it on to what you'd expect to do. Okay, you ready?
All right. Mississippi 1, Mississippi 2, Mississippi 3, Mississippi 4, Mississippi 5. I see, that's a lot more. Is it a lot more? I can't.
So it's 2.5, maybe 2.5. Okay?
That wraps up the projects for today, and we did a lot of work. Did it make much of a difference to the house? There are a few ways we can measure our effectiveness. At the beginning of the workday, the blower door test read 5,000 CFM, or cubic feet per minute. Due to all the air sealing measures implemented that day, the final blower door test read 3,800 CFM. That's a 24% reduction in the leakiness of the house. Once a few more measures are taken, including the sealing around the chimney, the reduction will be even greater. Another metric we can look at is the house's gas utility bills. The workday was held toward the end of November last year, so we have only a couple months' worth of data to look at. And there are factors that affect heating usage, such as weather conditions and usage patterns. But let's take a look anyway. The gas usage for December of 2008 and January 2009 averaged 273 therms. For December 2009, January 2010, they averaged 215 therms. That's a 21% reduction in average gas usage over the 2-month period. Today we learned about the way in which heat is lost from a home and measures homeowners can take to reduce their heating, electricity, and water bills. We partnered with the Home Energy Efficiency Team and the RMLD to weatherize an Arc of East Middlesex home here in Reading. We reduced the leakiness of the house and the gas required to heat it. So what's next? We plan to do similar weatherizing workdays on other Arc of East Middlesex homes in Reading, seek grant funding to extend the program, and get a volunteer workforce together to help. Interested in joining us? Email us today.
Do